We're going to look at graphing a quadratic function. First off, just a little bit of information about the term polynomial. Prefix of poly means many. Nomial is the root word where terms come from. So it's a quadratic is a polynomial, meaning it has many terms. A quadratic function is going to be in standard form, where its domain is the set of all real numbers. The parent function is just your basic quadratic. It gives you that U-shaped look, where you see that there are no gaps, breaks, or holes in the function. It's continuous, therefore the domain is the set of all real numbers. In this example, x squared minus 4, we're going to create a table of values and just graph this particular function. Because I like to keep the numbers simple, I like to use 0, 1s, and 2s and negative 1s and negative 2s as much as possible. But sometimes that will be determined based on some characteristics we'll look at in just a moment. But I evaluate the functions for the values for x. I plug in negative 2 and I square it. That gives me a positive 4. Minus 4 gives me a 0. And so I continue on and I can plot my points. And I see that I have a vertex at 0, negative 4. Well, that vertex is either going to be a maximum or a minimum, and in this case it's a minimum. It's the lowest point of where the function changes from decreasing to increasing. Your quadratics are either going to have one or the other, a maximum or a minimum. Sometimes they're easy to locate, other times it requires a little bit more mathematical effort to identify the vertex. Alright, in this example, we're going to use the previous problem and talk about the axis of symmetry. The axis of symmetry's characteristics mainly are one of them is it passes through the vertex. Okay. And because it is a vertical line, we're going to use the equation x equals whatever the value is of where it crosses the x-axis. And that will give us the equation of the axis of symmetry for that particular polynomial. Now, to graph a quadratic, we first really need to locate the axis of symmetry because that's going to set the stage for our table of values. And we get this nice little formula for the axis of symmetry where it's x equals negative b over 2a. Of course, all of this is based on the function in standard form. So here is our function that we're going to use for our example. We need to go through and identify the coefficients of a and b and the constant c. And those are pretty straightforward. Now I'm going to make the substitution into this formula for the axis of symmetry and identify that. So when everything is plugged in and simplified, I see that the equation for the axis of symmetry is x equals negative 3. That's going to come in handy in just a little bit. And remember, it is a vertical line that passes through negative 3 on the x-axis. Now we need to determine the vertex, or the coordinate of the vertex, sorry. Because we have already determined the axis of symmetry, that gives us a clue in what to use for x. Because we just realized that, or determined that x is negative 3. So that's going to actually make up the x coordinate of the vertex. Now it just becomes a matter of plugging this negative 3 in and simplifying the quadratic. Just remember, when you square a negative, it becomes positive. Okay, that's a common mistake right there. So there we have our vertex. The coordinate of our vertex is negative 3, 0. So not only do I know where the vertex is, I know where the axis of symmetry is. And so that's going to allow me to set up my table of values. Earlier I said I like to use 1s and 2s and negative 1s and 2s and 0s. Well, that doesn't always work out so well because of the axis of symmetry's location. Here it's negative 3, and what I like to do is I like to pick x values that are 1 unit and 2 units to the right and left of the axis of symmetry. And so you'll see it as I set it up here in my table. Alright, so I have my x values that I'm identifying. There's my vertex and the coordinate of the vertex. So I'm going to pick two values that are less than negative 3 and two values that are greater than negative 3 for x. So those values are less than negative 3. These values are greater than negative 3. So that's going to allow me to have a nice symmetric set of points to graph this, because when I plug in the negative 5 and I evaluate it, I know that because of the symmetry that negative 1 is going to be a reflected point, negative 1 comma 4. And then I can go and evaluate the negative 4 or the negative 2, and whatever value I get for that, it's because of symmetry, it's also going to be the y coordinate for the other value as well. So there's a look at graphing a quadratic. I know we have calculators and all kind of devices now that do that for us, but we still need to have the capacity to graph these by hand to understand more about what we're looking at and why the values we get are what they get, because sometimes it doesn't always just explain itself through a calculator. So thanks for watching.